Hello and welcome to Speranza Guesses the Methods exam, the series where I guess the methods exam so you don't waste your holidays and you do some study instead. I've just been doing some handiwork around the house, so let's get rid of that and let's do some maths. Alright, so we're back to the tech-free questions here, multiple choice, give yourself 90 seconds. And I'm going to solve it in 3, 2, 1, let's do it. Alright, it's a log function, y equals a log base e, just ln, x minus b, where a is less than 0 and b is greater than 0. And the secrets are in this bit here. Alright, so we know that a is less than 0. That means that this a value is negative. Maybe it's like -2 or something, I don't know. Alright, so it's negative. A negative log graph is not going to be shaped like this or like this. So we can get rid of these two. Alright, and finally we go to this b. b is greater than 0. So let's say b is equal to 5, right? Greater than 0. That means that this still says x minus positive 5. So this whole equation now is y equals -2 log base e x minus 5. All right, that means that the asymptote of a graph that's x minus 5 is going to be at x equals positive 5. So this is our answer. All right, see, it gets a little bit confusing, but you need to make sure that you're sharp about that less than and greater than. All right, so next question here, still tech-free. Give yourself 90 seconds, go. And I'm going to solve it in 3, 2, 1, let's do it. It's a normal distribution with a mean of 12 and a standard deviation of 0.5. Z has a standard normal distribution and the probability that x is less than 11.5. All right, here's 11.5 here. Boop, 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 boop. Okay, looking at the picture, I'm going to solve it a different way in a second, but looking at the picture, you can see that the number 11.5 is exactly one standard deviation less than the mean. Z-scores tell you how many standard deviations you are away from something. And so we are one standard deviation less than the mean, minus one standard deviation. This is going to be my answer here. Actually, interesting. Less than -1. All right, so I think the answer should be probability that Z is less than -1. But you can see that that's not in these options. I've got Z is greater than -1, less than this, greater than 1, da 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 da. Okay, so what am I going to do? Well, this probability here is equal to this probability here. Right? The probability that something is less than 11.5 is going to be equal to the probability that something is greater than 12.5. Because I'm less than one standard deviation below and I'm less than one standard deviation above. Symmetry. So I can say that the probability that Z is less than -1 is equal to the probability that Z is greater than +1. Is that in my list? Yes, C. All right, really clever question here because it tests your understanding of normal distributions and your testing of that sort of symmetry idea. Of course, if all this drawing pictures is a little bit uncomfortable for you, you can revert to this formula, Z equals x minus the mean over the standard deviation. So the x score here is 11.5 minus 12 over the standard deviation, which is 0.5. We get -0.5 over 0.5, which is -1. A z-score of -1, this should lead you, this z-score of -1 should lead you to this idea here, but in order to make the leap to this idea, you still need to understand that symmetry, or you need to see these as equivalent probabilities. All right, those two were fun. Let's do some short response. All right, good luck with this one. It's a sample proportion style question, tech-free. 3 marks, so only about 5 minutes on it. Have fun. and I'm going to solve it in 3, 2, 1. Let's do it. All right, so this is a really cute question. I really like it because when you get stuck into it, it's actually really straightforward. When you jump into a question like this, you should refer to your formula sheet. Specifically, there's a thing in our formula sheet, the confidence interval thing. That's really going to help us. And it's this margin of error bit of the question that's really interesting. So this bit here calculates our margin of error. So we know that one margin of error, it was found that the corresponding margin of error in the second sample was half that of the first sample. All right, let's write that down as a formula here, right? So the first sample's margin of error, z square root proportion 1 minus proportion over the size of sample 1, all right, is equal to, it was found that the corresponding margin of error in the second sample was half that of the first sample. All right, so that means that 2 times that margin of error of the second sample will equal the margin of error of the first sample. 2 times the z-score, p 1 minus p over the size of sample 2. Okay, and we can start messing about with this. Now, I can divide both sides by z. So it turns out that this 99% confidence interval thing, because z for a 99% confidence interval is 2.58. But it turns out that for this specific question, those z-scores don't really matter at all. Okay, so what else can I do here now that I know that those z's cancel each other out? Well, these square roots seem problematic, right? So what if I was to square both sides? Well, if I square the left-hand side, I just get p1 minus p over n1. And if I square the right-hand side, you need to be careful here because you need to square that 2 as well. So 2 squared is 4, and then it's 4 times p1 minus p over n2. All right. So what can I do here now? If I divided both sides by p1 minus p, p1 minus p, I'm just going to have 1 over n1 equals 4 times 1 over n2. And of course, 4 times 1 over n2 is just 4 over n2. Okay, and the question was, what is the ratio between n2 over n1? So, if I get n2 over n1 over here, n2 over n1, I get an answer of 4. So, I am finished. What is the ratio of the two sample sizes, n2 to n1? The answer is 4. Or if you want to write it kind of as a ratio, the answer is 4 to 1. Within the context of the question, that means that the second sample was 400 people and the first sample was 100 people, or something like that, a ratio of 4 to 1. So I really like this question. I'm really drawn to these kinds of questions because at first glance, it just looks like there's not enough information here at all. You're not told the proportion, you're not told sample sizes. It turns out that 99% confidence interval thing, you could have not had that. You could have been able to do this question even if they hadn't have told you that. So even with none of those things, you can still answer this question. So I really like this. So when you see questions like this, where you think, wait, there is nothing in here, there's no information here, go and look for a formula. Look for a formula that has something to do with the question that you're dealing with, and then start playing with it. And you'll start to see that actually it doesn't matter. I can do it anyway without that question, without that information. All right, neat question. All right, let's move on to a last one, and it's going to be on everyone's favorite topic, I hope. Before I do, I just realized that I last minute change, I made the number wrong. So let's call that question 17, which makes the next one question 18. All right, so it's a bigger question here, 7 marks. That's about 10 minutes on the clock. Give it a try and I'll come back. And in 3, 2, 1, let's do it. Okay, so we know the volume of the brick is 1,000 centimeters cubed, and we want to determine an expression for y in terms of x. So it must have something to do with the volume, right? And we know that the volume of any prism is equal to the area of the base times the height. Area of base times the height. Now we know that the height is y, and the big problem here is finding the area of the base. Okay, I've got an equilateral triangle for a base, right? X, X, X. Equilateral triangles have an angle here of 60 degrees. And I know to find the area of a triangle, I do have a formula for that on my formula sheet. So an area of a triangle is equal to half BC sine A. So half BC, so x times x, half x squared, and then sine of 60 degrees. And we're going to multiply that by y. Now, of course, sine of 60 degrees, we can do a little standard triangle here if we want to. 1, 2, root 3. And this is our 60 degrees. Opposite, okay, so we've got root 3 over 2 there. So 1 half x squared times root 3 over 2 times y equals the volume, and we know the volume. The volume is 1,000. All right, and now we just need to rearrange that to get y as the subject. All right, so I've just rewritten it here to give me some more space. Because this is a multiplication all the way through here, I'm just going to write it as a single fraction. So it's x squared root 3y on the top, and 2 times 2, 4 on the bottom. And now I can move everything over to the left-hand side except the y. So y is equal to 1,000 times 4, which is 4,000, divided by x squared root 3. I think I have an answer there. Okay, so part B of this question says, show that the total surface area this time of the brick is given by this formula here. All right, total surface area. So the total surface area of this prism will be equal to the area of this triangle plus the area of this identical triangle here. So area equals 2 triangles plus 3 rectangles, right? This rectangle plus the other rectangle plus the other rectangle plus 3 rectangles. All right. Now, the 3 rectangles are the easiest ones, x times y. So the area of one rectangle is x times y, so the area of 3 rectangles is 3xy. And the triangles, well, we already found the area of one triangle. We know that the area of one triangle is equal to half x squared times root 3 on 2, which is x squared times root 3 on 4. 2 times x squared times root 3 on 4. And 2 divided by 4, that's the same as 1 over 2. So I can change that to just over 2. All right, that feels really good to me because you can see this part here, and that part there. All right, and that leaves us with 3xy is supposed to be equal to 4,000 root 3 on x. So we originally know that y is equal to 4,000 on x squared root 3, so we can sub this part in to this part. This is pretty classic optimization question stuff. So we get the thing that we already knew about the triangles, x squared root 3 on, that's a 2, plus 3x times 4,000 on x squared root 3. And then when we sort of put this bit together, we get x squared root 3 on 2 plus, we got 3x on the top and x squared on the bottom. So that's going to leave us with an x on the bottom, x root 3 on the bottom, and then 3 times 4,000, which is 12,000. Let's leave it like that for now. All right. Now, the way that they're getting to this last step is by rationalizing the denominator. X squared root 3 on 2 plus, here we're multiplying top and bottom by root 3. So we get x, root 3 times root 3 on the bottom will be x times 3, which is 3x. And here we get 3 times 4,000 times root 3. And of course, you can see here that 3 and that 3 will cancel each other out. And we end up where we were supposed to end up, which is 4,000 times root 3 over x plus x squared root 3 on 2. All right, probably one more line here to neaten it up. All right, so that's pretty decent. Now, in conversation with the QCAA, I would suggest that this question wouldn't appear exactly as written on a QCAA paper because of the fact that you have to rationalize this denominator. So they probably would have been happy with they would have worded the question slightly differently and asked for something slightly different. Instead of saying show that was true, which requires someone to be able to rationalize that denominator, they probably would have asked a question that looked more like that, which would have allowed you to stop at this line and just do 3 times 4,000 is 12,000. So if that rationalizing the denominator bit scared you a little bit, I really don't think it's the sort of thing that you'll see on a QCAA paper because it's not within the syllabus and it's sort of not in the official Year 10 syllabus either. And that brings us to the last step, which is determining the value of x for which the brick has a minimum total surface area. So we're thinking about minimums we're deriving, right? So if we find the derivative of that and let the derivative equal 0, we'll know the value of x for which the brick has a minimum total surface area. So A equals, it's going to be easier for me to derive this if I write it as 4,000 root 3 x to the negative 1 plus, and this one can stay as it is, or let's write it as 1/2. No, let's write it a little bit strange here. Root 3 over 2 x squared. All right, that's easier for me to derive. A dash, the derivative of that, is going to be equal to power out the front, so negative 4,000 root 3, decrease the power by 1, x to the negative 2, plus power out the front, that leaves us with root 3, because we multiply by 2, and x. We'll write that now as 4,000 root 3 over x squared plus root 3x. And that is our derivative. To find the minimum, we let the derivative equal 0. So 0 equals negative 4,000 root 3 over x squared plus root 3x. Best play here, I think, is to move this to the other side or add it to both sides. So we've got 4,000 root 3 on x squared equals root 3x. And then multiply both sides by x squared. We'll get root 3x cubed equals 4,000 root 3. It looks like I can divide both sides by root 3 now, so finally get rid of that ugly looking thing. 4,000 is equal to x cubed, which means that x is equal to the cube root of 4,000. And I think that is my answer. Determine the value of x for which the brick has a minimum total surface area. X is equal to the cube root of 4,000. But how do I know it's a minimum? For that, we're going to want our second derivative. So a dash was equal to, let's write it in this form because that's definitely the easiest one to deal with. negative 4,000 root 3x to the negative 2 plus root 3x. Alright, when we find the second derivative, that's going to be equal to, bring the power out the front, so negative 2 times negative 4,000 is positive 8,000 root 3. We get x to the negative 3 plus root 3. Alright, that x to the negative 3, that feels ugly, so let's put it on the bottom as x to the 3. Okay, now, what do we know? We know that something's going to be a minimum when the second derivative is greater than 0. Alright, so sub x equals the cube root of 4,000 for x in the second derivative. Now, when I do that, let's look at it. The only x value is there, right? Now, the cube root of 4,000 is a positive number. So 8,000 root 3 is a positive number. A positive number divided by a positive number is a positive number, plus a positive number. Sub x equals cube root 4,000 for x in a double dash. We know that a double dash will be greater than 0 at that point. Therefore, a is minimum at the point we just mentioned, the cube root of 4,000. All right, I think I'm done there. Let's tick it off. So 2 tech-free multiple choices, 2 tech-free short responses. We have 6 questions to go. You really should have seen a lot of things here, and you should have seen some things over the last 7 videos, that you can do something with, right? It's all well and good to watch me do these things and say, oh, that was interesting, oh, that was interesting, but you really need to start doing those things yourself. So grab a pen and paper, grab your textbook, grab whatever it is that you've got, and start practicing. Practice, practice, practice. See you for the next one.